Hi, good afternoon, everyone. The aim of today's session is to take you through few of the questions from past years based on whatever we have covered till now in our classes. So, the questions are going to be based on these topics, beta, whatever we have covered in class. So, we have gone ahead and done Kinged ICs. We only saw this kind of question yesterday also. This came in IIT last year's paper. It was a NAT question. That means no option will be given to you. You have to simply give the answer. It's a 2 marks question. You have to fill in the blank, right? So that's the first kind of question that came in exam. Clearly, Kinged demand curve is very important because you get a 2 marker question from it. So that's the first that we will discuss. Then the second topic that you should be very aware of is clearly budget lines. It is ICs. So, we will be going ahead and focusing on budget line and IC also. There are few questions I will be showing you. Within IC, we have gone ahead and seen Marshallian demand of different kind of ICs, right? So we saw Marshallian demand of min function, Marshallian demand of max function, Marshallian demand of substitute goods. So we will see how such questions are also asked in the past year paper and how to solve those questions. Other than that, beta, if you go to your basic videos now, you will see chapter on elasticity. Very basic chapter now. You must read that also once. In almost every exam, you will see question based on elasticity. So we have to be well aware of such kind of questions of what is elasticity, of how do we find elasticity using different methods. So you will find the video on your platform, but I will show you that question also comes in the IIT exam. So then see here, this is a quasi-linear function. We have gone ahead and done the Marshallian demand and Hicksian demand of quasi-linear function. It has come in IIT exam. Note that this is a substitute good function. We have done Marshallian and Hicksian demand of substitute good. That kind of question can come in exam. Then these are GATE exam papers, beta. Again, substitute good. But this is very interesting. It is substitute good with constraint. So I will show you how to do that. Then it is complementary good. And then this is what we discussed in the class, monotonic transformation. So let us go ahead and start taking one question at a time. And let us start solving these questions. As and when we complete a topic in our class, we will go ahead and take such marathons and we will go ahead and discuss all the past year questions related to the topics that we have covered in the class. Okay, come to the first question. But the utility function given to you is max 0.5 x1, 0.5 x2 plus min x1, x2. This is the utility function given. Read the question. It says she has positive income Y and faces positive prices P1 and P2 for good 1 and 2 respectively. P2 is given to you as 1. There exists a lower price P1 bar such that if price is greater than P1 bar, then unique utility function choice is to buy only good 2. So beta, you have to find when will a corner solution exist and when will you consume only good 2. This is what the aim is. But before we do that, as we have been doing in the classes, we should be plotting IC. With practice, this should not take more than 2, 3, 4 minutes for you to do the entire question. But because we are still doing this, let us just try it. So beta case 1. Kya hoga? When, please do it along with me only, when x1 is less than x2. If x1 is less than x2, clearly, if I multiply 0.5 on both sides also, 0.5 x1 will be less than 0.5 x2, right? So out of the two, what will be maximum? Clearly 0.5 x2 will be more, right? So maximum will be 0.5 x2. And out of the two, what will be minimum? Clearly x1 will be minimum. X1 is less than x2. So x1 will be minimum. So my utility function will be 0.5 x2 plus x1. When will this be my utility function? When x1 is less than x2. Now take the next case. Case 2. When x1 is greater than x2. But if x1 is more than x2, even if I multiply half on both sides, then 0.5 x1 will also be greater than 0.5 x2. Na? If this is the case, my utility function will be, so out of the two, what is the max value? The max will be 0.5 x1. And out of the two, what is the min value? The min value will be x2. This is if x1 is greater than x2. Then you can go ahead and take some values. So let's say utility level is kept at 4. If I will keep utility at 4, what will I get from the first utility function? I will get 4 is equal to 0.5 x2 plus x1. So I can just keep this like this. When x1 is 0, if I plug in 0 here, what will be x2? X2 will be 8. And when x2 is 0, if I plug in 0 here, x1 will be 4. Right? This is for the first one. Try a similar thing for the second case. So we can have 4 is equal to 0.5 x1 plus x2. When I will keep x1 as 0, x2 will be 4. And when I will keep x2 as 0, x1 will be 8. Right? So I have to go ahead and plot these two utility functions, these two lines. So look here, this is x1, this is x2. This line has the intercepts when x1 is 0, x2 is 8 now. So 8 here or 4 here. This is the line. Let me just draw it like this. For this line, what is your utility equation? 0.5 x2 plus x. Better look at the second one. This line is either 0, 4 or 8, 0. So the line that I will be having will be like this. This is 4, this is 8. And this equation of this line will be 0.5 x1 plus x2. Right? Again, you can go ahead and find the kink line also by equating the two lines. So 0.5 x2 plus x1 is equal to 0.5 x1 plus x2. So you will get from here x1 is equal to x2. This is the line of kink you're having. Now, what did we do? We do that here you have x1 less than x2. And here you have x2 greater than x1. Sorry, x1 greater than x2 and x2 greater than x1. So when x1 is greater than x2, what is the equation that we have? When x1 is greater than x2, the equation is this one. 0.5 x1 plus x2. So we have 0.5 x1 plus x2 in this region. And when x1 is less than x2, what's the equation we have? 0.5 x2 plus x1 in this equation. So beta, the shape of the IC is much clearer to us now that in this case, our IC looks like this. What is this part equation? This is 0.5 x2 plus x1. And this is 0.5 x1 plus x2. What is your MRS in this case? MRS is MUX by MUY. So MU1 by MU2. When you will differentiate this with respect to x1, you will get 1. With respect to x2, you will get 0.5. Beta, 1 divided by 0.5 is 2. Here, dekho, the MRS is going to be MU1 by MU2. When you differentiate with respect to x1, 0.5. With respect to x2, 1. So you will get 0.5. So this has a slope of 2 and this has a slope of half. Now, I will not do all the cases. We have done this multiple times in class. Just come to the case that has been asked. When will you buy only good 2? So you will buy only good 2 if your equilibrium is here. That means somehow in my mind, I can think that my budget line must have been like this. Right? This would have been my budget line, very, very steep. Right? So, beta, if Px by Py, this is greater than 2, greater than half. That means it is simply greater than both the MRS. One MRS is half and other MRS is 2. So if Px by Py, in other words, is greater than MRS, then what do I get? I get consume only good Y. Because good Y is cheaper. Right? It's given to me that the price of the other good is 1. So given that Py is 1. So I want Px by 1 to be greater than 2. Right? I simply want it to be greater than 2. It has to be very, very steep. So this means that I want my Px to be greater than 2. So the minimum value of the price for which I will be consuming only good Y will be 2. So that's the answer to your question. The minimum P1 bar, that is what it is asking. Price should be greater than what value? It should be greater than 2 for me to be on the Y-axis and consume only good Y. So you see how, I mean, not every time the same will come. We have done so many different kind of kinked questions, right? And any kind can come in exam. But this is how you have to go about the approach. Now it took me 15-20 minutes because I was explaining you. In exam, you should not be taking this much time. You have to practice all those assignments, all those questions multiple times so that in exam it is quicker for you. You have to do 60 questions, right? So it has to be very quick for you in exam. Okay. Now better come to the next question. You can see how with time IIT has increased their level. 2023 people found the paper very difficult as compared to 2021. So this year it's going to be even more tough. I'm telling you in advance. Okay, come to question number 48 now. This is a consumer always spends 50% of his monthly income on food. Introduction of value added tax on food item has led to 20% increase in price of food, while his income has remained unchanged. Consumers' price elasticity of demand for food is. So beta, this is your expenditure or revenue method. Very commonly asked in multiple exams, not only in IIT, but in CUET also, in IGIDR also, multiple GATE also. This expenditure or revenue method is asked a lot of times. So what is this? This basically is, so A, if price increases, revenue or expenditure increases, or price decreases, revenue or expenditure decreases. That means they move in the same direction. Then it is inelastic. Second, when price increases, revenue decreases, or price decreases, revenue increases. That means they move in opposite direction. Then it is elastic. Third, when price changes, but your expenditure or revenue is unchanged, then beta it is unit elastic. Now our question clearly suggests that it is unchanged. I will always spend 50% of my income. My expenditure is always the same, and income is not changing in the question. So, if my income is 100, I am always spending 50 rupees on the good, 50% of my income. So this expenditure has remained unchanged, even when you introduced the tax, right? So which means that it should be unit elastic. Elasticity should be 1. And that's the answer to this question. So elasticity should be 1. Okay, come to the next question. This was pretty simple. And you see this is 21 paper. Now it says the utility function given is x1 plus 2 root x2. So yesterday in the group, one of you had asked me, ma'am, will utility function of quasi-linear be always, will you always have convexity being followed, or will you always use the MRS equal to PX by PY equation or not? No, I've given you the example of exponent also, right? So you have to check that MRS should be diminishing for me to be able to use MRS equal to PX by PY. Only then I will go ahead and use it. Okay. So, okay.
Excuse
so
me,
this
ma'am.
is, yes.
In the previous question, the answer will be 1, but over there it's written -1.
Because this is demand elasticity, right, beta? So elasticity of demand is always negative.
Yes.
So this is a fill in the blank. Usually they will give you marks even when you write in absolute values. But yes, because it is elasticity of demand, it should always be negative. So it's a good idea to put a minus sign. Okay. Okay. Come to the next question. So utility function is x1 plus 2 root x2. And it says that you are initially consuming x1 as 10 and x2 as 10. And now it says income increases by 50%. Prices are unchanged. What will be the demand of x2? So let's see. Utility function given is x1 plus 2 root x2. Initially, x1 star is 10, x2 star is also 10. This is given to me. Now, prices are unchanged. Income increases by 50%. It is asking what should be x2 star now. But note that this is quasi-linear preference. And this part, it is coming non-linearly. So when we talk about the utility function, what will be my MRS? MRS will be mu1 by mu2. So when I differentiate it with respect to good 1, it is 1. And with respect to 2, I will get 2 into 1 by 2 root x2. So it will be root x2. If I equate MRS to px by py, I will get root x2 is px by py. So I will get x2 is px by py whole squared. X2 is not getting affected by the level of income. Whatever comes non-linearly is not affected by income. If it is not affected by income, then when income increases by 50%, it does not matter. The demand should remain the same because there is no M coming in here. This is what we saw. So therefore, the consumption of X2 remain the same. So X2 will remain at 10 if you were initially consuming 10 units. Exactly, you're right. It's a necessity because it is not a function of income. So therefore, the answer will remain at 10. So the answer to this question will be 10. That's the answer to this question. Okay. But now I will first take the gate questions, then I will tell you what you have to do with these questions. So come here to the next question. Trisha's consumption preference on biryani and pudding is given by x plus 4y. The price per unit of biryani is 2. And price per unit pudding is 3. Trisha's total income is 120. So let's just write this information down first. X plus 4y So utility function is x plus 4y. Px is given to you as 2 and py is given to you as 3. And m is given to you as 120. But if I don't look at the remaining part of the question, then what should happen? I know that MRS is MUX by MUY. So this is coming as, when I differentiate this with respect to X, it should be 1. With respect to Y, it should be 4. So this should be 1 by 4, 0.25. If I look at PX by PY, this is 2 by 3, 0.67. Clearly, we can see MRS is less than PX by PY. So we can see that we will consume only good Y. So if no other information is given to you, then we know that I should be consuming only good Y. That should be my answer. But now read the question. She faces extra quantity constraint. She is not allowed to consume biryani more than 60 units and pudding more than 30 units. Pudding is good Y. She should be consuming all of good Y. So how much good Y should she be consuming? She should be consuming M by PY. Beta, income is 120. Price of good Y is 3. So she should be consuming 40 units of good Y and 0 units of good X. Ideally, ये equilibrium होना चाहिए था based on substitute goods. But now it is telling me that she can only consume up to 30 units. So maximum good Y that she can consume will be 30. But the price of each unit is 3. So 30 into 3 is 90. Her income is 120. Minus she has spent 90 on good Y. So her remaining income will be 30. She has to remain on the budget line. So this 30 must be spent on good X. Price of good X is given to you as 2. She has 30 rupees left with her. So how much X can be consumed? 30 divided by 2. 15 units of good X can be consumed. So she can go ahead and consume 15 units of X and 30 units of Y. This is an exceptional question where you are given substitute good, but additionally there is a constraint on the budget that you cannot go beyond some levels. I'm giving you this as a homework. Just try to go ahead and, give some time and post your answers on the group. Can you plot the budget line in this case? It is very simple, but just try and plotting the budget line. So this budget line will have constraints. Constraint on level of X and Y, right? Taking those constraints into picture, just try and plot the budget. Okay, and then just give your answer. Okay, now come to the next question. This came in GATE 2022 exam. It says, Mr. Sharma's consumption preference for tea and sugar is denoted by min of X, 2Y. So U is min of X, 2Y. And it says in the price of tea is 10 and price of sugar is 10. So PX is 10, PY is also 10. And income is 900. M is 900. What is the optimum tea of quantity of tea purchased by Mr. Sharma? Very simple. We know this. So equilibrium is at the kink. So we should have X is equal to 2Y. So PX into X plus PY into Y should be equal to M. But X is equal to 2Y. So PX into 2Y plus PY into Y should be M. So beta Y will be M divided by 2PX plus PY. Income is 900. Price of good X is 10. So 20 plus 10. So 900 divided by 30. And this is going to be 30. So Y is 30. What will be X? X will be 2 times of 30, which will be 60. So pretty simple question. They've just asked Marshallian demand. But as far as I can think, from this year onwards, maybe they will shift to Hicksian demand. So you should be very convenient in also finding the Hicksian demand. In this case, again, a homework for you, beta. Just find the Hicksian demand in this case, right? Although it will be in terms of utility, just try to do that. Just give me some answer for this utility function, find the Hicksian demand. Okay. Now come to this question. Most of the students were tricked in this question. Why? They started finding the MRS and they started doing different things with the question. Let's look at the question. Beta, the utility function, and we discussed this in the class also, is x square plus 2xy plus y square plus 4 alpha square plus 8 alpha plus 10. This is my utility function. Look that this is nothing but x plus y whole square. X square plus 2xy plus y square. So this is just x plus y whole square. Absolutely correct, Tanishta. It's going to be perfect substitute. Plus 4 alpha square plus 8 alpha plus 10. This is just constant. Just a constant. So ideally my root function in this case is u is equal to x plus y. Then I kept doing some monotonic transformation. I would have squared both sides. I would have added some constant on both sides where constant is this entire thing, and I would have got a new utility function. But in the background, the x and y part only constitutes of substitute good function. And now I'm given a constraint that 2x plus y is 10. So my px by py is going to be 2 by 1, which is 2. And my MRS will be MUX by MUY. If I differentiate this with respect to, so my root function is just x plus y, na? That's my root function. So x plus y MRS is simply 1 MUX by MUY. So this is going to be 1. I can see that MRS is less than PX by PY, which means you will consume only good Y. You will consume only good Y. No, beta. Monotonic transformation is always assumed to be increasing transformations, not decreasing. Although, had I subtracted this completely, I would have got the correct answer. But in case of utility, we assume that it should be an increasing transformation. Now, the original definition of monotonic transformation suggests that two utility functions, as long as they have the same MRS, one is monotonic transformation of the other, right? So even if I would have subtracted everything from here, when you would have found out the MRS, right? If that MRS is 1, they could differentiate it with respect to x, you would get 2x plus 2y. With respect to y, you get 2x plus 2y. So MRS is 1. As long as MRS is 1, we call it as a monotonic transformation. So definition wise, I just want to check this. But ideally speaking, you should have increasing transformations to the utility function, right? So to answer your question, even if it is decreasing, but MRS is same, you can apply the same. Okay. Okay, so coming back here, so beta, we have seen that MRS is less than PX by PY, so you consume only good Y. And only good Y means that Y star should be M by PY. Income is 10, price of Y is 1, so I will get 10 here. The part here which I find is a little difficult for students is that these are not MCQs anymore, right? In IIT, the last 20 questions that you will see are very tricky for students, not because they don't know, because they don't even have a way to check whether their answer is one of the 4 options or not. So that is why GATE and IIT have their own importance, and you should be practicing numericals a lot to get into those exams. Now, these were the questions that came in GATE and IIT, but I've tried to pick 2 questions additionally from DSE papers. DSE has asked a lot of these questions in the past. But as we know, DSE is now with CUET. There are less chances that CUET will give you that level of kinked demand functions, right? But still, basic questions like this can come. So let's have a look at this question. This is from DSE paper. I think this is 2006 or 7. Look at the function. Consider a consumer having utility function 2x plus y. Suppose px is 5 and py is also 5. This is given to. And m is 100. So practicing DSE will help you get into IIT also. That's the good part. So we know that MRS will be MUX by MUY. When you differentiate with respect to x2, with respect to y1, so you have 2. Px by py will be 5 by 5, which is 1. So MRS will be greater than px by py, which means you will consume only good x. How much x? M by px. M is 100, px is 5. So 100 by 5, which is 20. So 20 units of good x and none of good y. That's the answer to this question. Again, you just have to remember this rule and things would be fine for substitute goods. I'm leaving this as a homework to you. I want you to try this. It's a pretty simple question. Let me just hint you on this one. So this says you're given 2 consumers and you're given their demand curves. But a market demand is demand of individual 1 plus 2. Many students make this mistake that they will simply add these 2. That is incorrect. From here, demand, when you find market demand, it is horizontal summation, which means I must find what is the demand of first person, what is the demand of second person, and only then I should add it together. So from the first function, if P is 20 minus Q, this is demand of person A, Abhik. So demand of Abhik, if I have to find QA, it will be 20 minus P. Both face the same price, but both have different demands. Similarly, if I look at the second part, it is given that the demand by Brinda is P is equal to 5 minus Q by 2. This is demand by Brinda, B. So if I solve for QB, it is going to be 5 minus P into 2. That means 10 minus 2P. I have QA, I have QB. Now I can add the 2 together. I can only add demands together. Many students will simply go ahead and say, okay, total P is equal to 20 minus Q plus 5 minus Q by 2. No, that's incorrect. You first find the demand and only then add. That's horizontal summation, right? So once you have gone ahead and found out the 2 demands, then you can add them together. So the market demand, which is represented by capital Q, will be QA plus QB. Demand by individual A plus P. 20 minus P plus 10 minus 2P. This is capital Q. This is the demand. So you have got the market demand. You have got the market supply curve given to you. This one. P is equal to 2 plus Q. See, Q is capital here because it is market supply. And now I have market demand also. Equate the two and find the equilibrium. So the first equation, the demand equation is this. The supply equation is P is equal to 2 plus Q. So Q will be 2 minus P. So just solve the two and get the answer for Q and P. So what is important here? Both are equal to P means, I mean, this directly to this, is it? No, we can't do that, right? So in the question, if you notice, this P is equal to 2 plus Q. So it is P is a function of capital Q. And here P is a function of small q's. So I cannot directly equate them. I have to go ahead and make this P also as a function of capital Q. And that happens here after I add the two demands together. Now P is a function of capital Q. So from here, if you can find the value of P, that will be 30 minus Q by 3. Then the other, this is the demand side. Supply side is 2 plus Q. Now, yes, you can equate the two with each other. But earlier you cannot. That demand is a function of individual prices, and this is the market supply. If that's the question you're asking.
The individual demand functions, can we equate those two to each other, like irrespective of the combined price? 2 plus Q?
No, we cannot. Because if we equate the two, we are assuming that somehow their demand curves are the same. We cannot do that. They face the same price, but it's at different, I mean, they're demanding different units, right? So how do we draw this usually? We say like this, that look, this is the demand curve of individual A. Whatever equation is given to me, this is A, suppose. Suppose some other equation says this is the demand curve of individual B. One can be steep, one can be flat. Now, if I were to draw the market demand curve, I will hold price constant at any level. And I will say, okay, if this is the demand of A, at this price, this is the demand of B, then what is the market demand? So at the same price, this was A, add B to it. So maybe a very flat market demand. I have to find this to equate to the market supply curve. That's what the process we are following. Okay. Okay, so that ends all these questions that we had to discuss today. Now, whatever we have, whatever I've highlighted, just do those things in the background. And then at 4, you will have your regular weekly microeconomics test. Try to do the test today itself. It will be based on utility preferences, and it will be based, maybe some other questions on budget line can also be asked. Okay, thank you.